Hello and welcome. This is going to be our lecture video for February 1st to 2nd. Let's go ahead and get started with a little bit of review. So here's our generic exponential equation. Over what intervals of b is the equation exponential growth / decay? All right, so if b is greater than 1, that means we're repeatedly multiplying by a number bigger than 1. You multiply by a number bigger than 1, the equation will grow. So if b is greater than 1, the equation is exponential growth. All right. The next option is that b can be between 0 and 1. So we can express that 0 is less than b is less than 1. The equation is exponential decay. All right, and then if b is exactly 1, then we're just multiplying by 1 to some power, but that will always be 1, so it will neither grow nor decay, it will just be constant. And if b is negative, some really strange things happen, because a negative raised to an odd number is negative, but to an even number is positive. So it would be flipping back and forth between being positive and negative, really a pretty chaotic graph that would create. All right, let's practice graphing a little bit. Here's our equation. Y equals 4 times 2 to the x plus 2. So first thing we want to do is add in a horizontal line at that last number. We say this is the table Alice is standing on. That is our horizontal asymptote, and we'll label it as y equals 2, our horizontal asymptote. All right, Alice can never go lower than this horizontal asymptote here. Now, her height, we're going to say she starts at 4 feet tall, but she's standing on the 2-foot table, so her head is up at the 6. That's our y-intercept, so y-intercept is 6. Now the strength of the cake, it's doubling cake. So she was 4, now she's going to be 8 tall, but her head will be at the 10. Then she'll be 16, which will put her head at the 18, and then she'd be up at 32, or she would double again to 32. The next point would be up at 34. But now we can also go backwards with this. If she's currently 4 feet tall, then going back in time, she must have been 2 feet tall, and then 1 foot tall, and then a half foot tall, and we'll flatten out to the line on this side. All right, if we multiply by 2 to move forward in the graph, then we must divide by 2 to move backwards. If we connect this up, we start with a line that's basically flat to that horizontal asymptote before it takes off and hits these points, and then curves very, very steep. This is much steeper than even a quadratic parabola. All right, I think we answered all of our questions there. Let's try one with exponential decay. Again, we start by putting a horizontal line at the last value, the k value is what we could call that. All right, then we're going to say Alice is 3 feet tall, so standing on top of this table, her head would be at the 4. But this is the shrinking beverage. This is going to make her half as tall as we move units forward. So she was 3, now she's going to be 1.5, then 0.75, and then 0.375, and so on, and flatten out to the line in this direction. But then if we go backwards, so now we're essentially dividing by 2 to move forward, so we'd multiply by 2 to move backwards. Multiplying by 1/2 is basically the same as multiplying, or dividing by 2. So multiply by 2 to move backwards. She is 3, so next she'd be with 6, which would put her head at the 7. Then she would be 12, which would put her head at the 13. And then she'd be 24 and we'd be off the graph. And I connect these up I start very steep, come in, hit my y-intercept, and then flatten out very quickly. To the point where we're basically this flat line here. Okay, so my horizontal asymptote was y equals 1. The y-intercept was 4. It's always going to be your a value plus your k value. All right. So that was just a little bit of review of graphing. But our real goal today is to be able to answer questions about investing money with different interest amounts and compounding periods. While we're doing this, you could use this information to help you invest and pick the right loans. Okay, so first thing we need to cover is how do I increase a number by a percent? What number would I multiply by if I wanted to increase an amount by 4%? So if you answered 0.04, you're halfway there. What you need to multiply by is 1.04. That way you get your whole amount back. You multiply anything by 1, it just returns that same number, plus an additional 4%. If you just multiply by 0.04, you would get just the increase, and then you would have to add it back in. By doing the 1.04, you get the full amount and the additional all in one step. All right, what if I want to increase something by 60%? I bet you can figure this out. You multiply by 1.6. That way you get your full amount plus an additional 60%. What about 0.05%? Move the decimal twice, and we end up with 1.005. Watch out, if you only did 1, 0, then it would be equivalent to 5%, not 0.5%. All right, move the decimal twice on this one, add our 1. If I want to increase something by 230%, I have to multiply it by 3.3, which makes it seem like you'd be increasing it by 330%, but not really, because you got to remember, we always add 1 in to get the whole amount back. So when you add 1 in to a number over 100%, now all of a sudden you have a number like 2 or 3 or 4. And it looks a little strange, but that would increase it by 230%, not 330%. All right, let's talk about simple interest. So you have $300 in an account, and it grows by 2% every year. Use simple interest to find the amount in the account after 4 years. So simple interest says that 2% for 4 years. I'm just going to multiply those and get that that's basically like 8% once. So 8% one time. All right, so it's ignoring the effects of compound interest, not allowing interest to grow on top of interest, and just saying, I'll just add up all of my percentages and pay it out one time. Now, how do I increase my $300 by 8%? Well, we just covered that. We multiply by 1.08. Get a total of 300 times 1.08 is 324. So we gained a little bit of money. Okay, here is the formula for simple interest. If you just want to calculate the interest but not the final amount, you could just do PRT. But better is to get the total amount, and that's when you have to add in that 1, so that you're not just getting the interest, you're getting the full amount back plus the interest. So pause this if you want to copy this down. All right, let's talk about compound interest. You invest $500 in an account that grows 4% annually. How much will you have after 1, 5, and X years? So after 1 year, we're going to increase our $500 by 4%. So just take 500 and multiply it by 1.04. After 5 years, we're going to take our $500 and we're going to multiply it by 1.04 for the first year, times 1.04 for the second year, third year, 4th year, and 5th year. I'm not actually even going to calculate out what this is, just that's how we would get it. But here, I've got some repeated multiplication. Whenever I see repeated multiplication, I want to think of a way to abbreviate that. A way to abbreviate this would be to do 1.04 to the 5th. And now you might see the pattern. So after X years, to get my final amount, I'm going to take 500. I'm going to multiply it by 1.04 times 1.04 times 1.04 dot, 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 dot. I'm going to multiply it by 1.04 x number of times. So I can put that together as an exponent and just do 500 times 1.04 to the power of x. All right, and so what this does is it calculates all of your interest first and then just applies it to your principal. All right, thought question. Is it better to grow 1% every month or 12% every year? All right, I'll embed a question here for you to weigh in on this. All right, the one that I think is better is the 1% every month. And let me show you why. So let's graph a very rough sketch of our wealth over time using these two different strategies. So here, this will be money, this will be time in months. And let me put in, okay, so just a bunch of tick marks to represent all of the months for maybe about 2 years. All right, with the 12% strategy, we're going to start with some amount, and it's going to stay flat until we get a full year in. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 months should be there. And then we're going to get that 12% all at once. All right, but then we got to stay flat again and wait 12 more of these and then get all of our interest again and then wait. All right, so that is the 12% every year line. But now let's look at 1% every month. So we would start the same, but after a month we get a little payout. It's not much, but it starts to raise our account's value ever so slightly. And actually at the end of the year, we end just slightly above the 12% every year line. And that's because of the effects of compounding interest. After 2 years, the gap would be even larger. All right, so this is the 1% every month. And the reason for that is that future 1%s get to be applied to a larger amount. So it might add up to 12% by the end of the year, but because some of these 1%s got to apply to this amount, it gives you just a tiny edge that gets bigger over time as that 1% is growing on a bigger and bigger amount. You have interest on top of interest on top of interest. But this is also better because if I want to take my money out, halfway through the year, with the 1% every month, my money has had a chance to grow a little bit versus the 12% every year. It's just flat and then you get it all at once. So at every single point, I'm wealthier with the 1% every month. And the biggest gaps are right in here, around like October, November, got much more money, while this person over here is waiting for their interest to come in. Okay, so here is the compound interest formula. Copy it down. The big thing to watch out for is this n. N is the number of times per year the interest is compounded. So if we see something like annually, we're going to know n equals 1. If we see semi-annually, this means it's being compounded twice per year, so n equals 2. If we see monthly, n equals 12, and so on. All right, there's a lot of different terms we can put there. All right, so let's practice that formula. We have $200 in an account that advertises 8% annual interest rate compounded quarterly. How much can we expect the account to be worth in 3 years? So final amount A, we don't know that, equals our principal, we're investing $200, times 1 plus the rate, always express this as a decimal, divided by, so it's quarterly, that means n equals 4 times per year. So effectively we're taking that 8% and chopping it into 2% increments to be paid out much more frequently. All right, and then it's going to be n times t, so 3 times 4 up here. And what this means is that within 3 years, there will be 12 quarters to compound our interest. So my final amount equals my $200 times, this becomes a 1.02, and this becomes a 12. All right, so instead of getting 8% 3 times, I'm getting 2% 12 times, and that actually ends up netting me a little bit more money. So this we can just plug into our calculator. To the power of 12, and we get $253.65. All right, so just for fun, if we had only done the 8% for 3 years, so just compounding annually, we would have a whole $2 less. So with shorter time periods, compounding more frequently doesn't affect it too much. Where you really see the effect is with very long-term investments, where you're going 20, 30 years. All right, what does the following equation tell you about a certain investment? So now that the equation is filled in, can you tell me what this person invested? So the individual invested $220 at 5% compounded quarterly That's from that 4, means 4 times per year. What about the 17? Does that mean they left it in there for 17 years? Not quite. Remember, this is n times t. And we already know n is 4, so it's 4 times t equals 17. Divide both sides by 4, and we get that the investment grew for 4 1/4 years. So when we divide by 4, we get 17 over 4, which is 4 1/4. All right, the individual invested, I wrote 200, I meant to say 220. At 5%, compounded quarterly, the investment grew, and making all sorts of typos, 4 1/4 years. All right, I'll embed a few more for you to try here, but that's it for this lecture video. Have a good rest of your day.